Recording. Awesome. Okay. So broadly, the endocrine system and the nervous system work closely together. The main idea is that they are both involved in regulating body processes, maintaining, monitoring the chemical balances within the body, and making changes in order to maintain homeostasis. So that is your chief goal number one. Maintaining homeostasis. This is what the system does. We can broadly divide the endocrine system into two kind of broader categories. And those are the exocrine and endocrine. So exocrine glands, there is a common characteristic for all of them, and that is exocrine glands secrete via using a duct. Now, a duct is just a fancy word for a tube. And the reason that they use tubes is because of where they are sending the things that they secrete. They are sending things either to the surface of the body, i.e. the skin, for example, sweat or milk glands, right? Secreting their stuff out to the skin surface, or they are secreting it into a body cavity, like your salivary glands. So these glands will produce some material like sweat or saliva or milk, and then they contract using smooth muscle. They squirt their secretion through a tube to the body surface or to the inside of a body cavity. That is the big category. That's the chief thing that sets these guys apart from the other system. So we have ducts, and they secrete to the surface or some kind of body cavity. Endocrine glands, on the other hand, are ductless. They do not use a duct. They squirt their secretions directly into the bloodstream, and then the bloodstream carries them throughout the body. So endocrine glands secrete chemicals called hormones, and these hormones will go on to have discrete, meaning distinct effects on various cells in the body. So they are either secreted directly into the bloodstream, or they are secreted into the interstitial fluid, and then from there it will diffuse into the capillaries and then get picked up into the bloodstream in that way. So endocrine glands, these are the glands that you're probably used to hearing about, like pituitary, adrenal, thyroid, hypothalamus, your pineal glands, your thalamus. These are all endocrine glands. Now, the hormones that they secrete are also rather interesting. Hormones are chemical messengers. Now, we've seen chemical messengers before in the last system that we covered, in the nervous system. We were calling those chemicals neurotransmitters, and they were released across the synapse, and they included things like dopamine and serotonin and noradrenaline. Well, fun fact, hormones and neurotransmitters are largely the same thing, like the same chemicals. The difference is where they're made and where they're squirted. So if they're being made in a gland and squirted into the bloodstream, then that's a hormone. But if that same chemical is made in a neuron and it is squirted across the synaptic cleft, like across the synapse, then we call it a neurotransmitter. So the term that we use for these chemicals depends on which organ system that chemical is belonging to, but the chemicals essentially are the same. The difference between adrenaline and noradrenaline is where that chemical is active. It is either active in the body, as in the hormone, or it is active in the brain, as in the neurotransmitter. So hormones come in a lot of different flavors. One is the amino acids. So the amino acids are chained together to form what is called a polypeptide, also known as a protein. So some of them are protein-based. Some of them are steroids. Steroids are lipid-based, so they are based off of fats. And we have others called, I forget the name. It's in the PowerPoint down below us, but they're made from carbohydrates. So we're able to synthesize various different kinds of hormones. And hormones are accepted by specific hormone receptors. So only specific cells will have the receptor for that hormone. And those would be called target cells. And I'll give you a nice clean example. Every month in a woman's body, the pituitary gland sends a signal to the ovaries. That hormone signal sent to the ovaries triggers ovulation and begins her menstrual cycle. The only cells in the body that respond to that hormone are the ovaries. They are the only target cells. They are the only cells that have the correct mechanism on the surface of their cells in order to receive and respond to that hormone. All of the other body cells, they do not have that receptor, so they cannot react to it. That is what we mean when we say target cell. So endocrine glands are ductless. They secrete hormones. And they secrete those hormones to affect target cells. Target cells will be very specific. So hormones will bind to receptors, either on the surface of the membrane of the cell, or certain hormones are able to pass through the cell membrane very easily, and they will bond with receptors that are located within the cell, floating around like all the other organelles. When the hormone binds to a receptor, it will create a specific change within the target cell. Now understand the change that we're talking about, it's some complex chemical process that probably has like 17 steps and we don't need to know about it. We can just say a change happens and we massage therapists can move right along. The change that occurs will depend on the concentration of the hormone. So if there's a lot of this hormone being released versus, just a small trickle, the quantity of the receptors. So if the cell is very easily overwhelmed by the presence of a hormone, or if only a certain amount is able to be brought into the cell, the affinity of those receptors for hormones. Sometimes the receptors, for whatever reason, are not, what's the word I will use? They're not open to binding with these hormones. This could be something, for example, like depression, right? Your receptors just won't bind to the receptors, or to the receptors won't bind to the hormones. That's what I mean to say. Now, three things will generally trigger hormone release, and they're very broad categories. It's a very simple concept right here to understand. The chart makes it a little bit easier. So what is it that triggers hormones? Well, remember the main function here was to maintain homeostasis. So we've got to be monitoring all of the different chemicals that are found in the bloodstream, right? Things like blood sugar levels, things like blood calcium levels, all that kinds of stuff. So the first thing that can trigger a hormone release is what is known as a humoral stimulus. We're talking about fluids. We're talking about a change in the concentration of some chemical in the body. For example, we could be talking about oxygen level or blood calcium level. So we've got chemical concentration, the concentrations of certain chemicals in the body, whether those are acidic or alkaline chemicals or extra calcium or extra sodium, or again, not enough sodium or not enough calcium. We also have things such as neural stimulus. So the nervous system can trigger the release of specific hormones, for example, fight or flight. So when the brain perceives some kind of stressor, right, it signals through the autonomic nervous system, it signals the production of all of those stress hormones. It kicks in fight or flight response. And other hormones can be triggered. So the pituitary, for example, is known as the master gland because it secretes hormones that go into the body and trigger other glands to secrete their hormones. So it's the puppet master kind of pulling the strings around here. These are the things that trigger hormones to be released, right? So changes in chemical concentration, which means we need to rebalance to maintain homeostasis. The nervous system detects something and is using the hormone hotline to make changes in the body. Or other glands are secreting hormones that are triggering target hormone or target glands to release hormones. Now, the way these hormones work is by taking advantage of things called feedback loops. And if you read the explanations in the book or on the slides, they're very wordy and they're very technical, and you need kind of like an engineering degree to understand them. The basic concept is much easier to grasp. The basic concept of a feedback loop is when you have some system that is working, right? We want the system to be able to kind of monitor itself. So the main question that we ask when we're classifying these kinds of feedback loops is, what happens when you reach the threshold that you're trying to reach, right? You're trying to keep a gauge in a certain level. When you reach that goal and then keep going, what happens to the system? We got one of two options. With a positive feedback loop, right? We want to reach a certain threshold. Here's our graph. You want to reach a certain threshold, but with a positive feedback loop, it keeps going up. So once you reach the threshold, if nothing changes, the system just reinforces itself and we keep going on and on until the machine blows itself apart. With a negative feedback loop, right, what happens when we reach our desired threshold is that the system begins to cut itself off. So with a negative feedback loop, once you reach the act of reaching some threshold triggers another thing to happen that starts to dampen the effect, and it brings us out of this critical mode. With a positive feedback loop, the opposite happens. When you hit a certain threshold, that chain reaction just keeps it rolling and it just gets bigger and bigger and bigger. Now, with that kind of basic idea, now when we start talking about using negative feedback loops or positive feedback loops, what we're getting at here is we are constantly secreting hormones that have opposite actions of one another, right? One will raise blood calcium level, the other will lower blood calcium level. And the trick with these feedback loops is once we reach an optimum level of, let's say, blood calcium, then it triggers the release of the dampener so that we start to take calcium out of the blood. These two are constantly at play. No one ever wins. They are on the same team. The goal, like the brakes and the accelerator of your car, they work together to make sure that we maintain homeostasis. We want to make sure that we maintain a level amount of blood calcium. Good stuff so far? Good stuff so far, everybody?
Okay. Good stuff.
Good stuff.
Good stuff. Awesome. So with a negative feedback loop, right? This kind of idea that I just tried to explain here with the graph, right? The hormone acts to reverse the stimulus that causes its release. So once you've hit some threshold, now the hormone is going to cut off the source that was keeping the amount of hormone rising. So for example, insulin that is released in response to high blood sugar, when your blood sugar gets too high, you release insulin. What insulin does is it bonds with sugar and allows sugar to be taken into the cells. If the sugar goes into a cell, it is taken out of the bloodstream. So the effect is the blood sugar gets lowered. So the insulin has acted to reverse the stimulus, the rise in blood sugar that triggered its release. Good stuff? Good stuff. So with a positive feedback loop, the hormone instead acts to increase the stimulus that causes its release. So here, when we reach some threshold, we are going to reactivate the same stimulus, and that is going to keep the amount of hormone in the bloodstream continuing to rise. So when a woman is in labor, every time the cervix becomes stretched, because there's a baby being pushed through there, the brain releases oxytocin. This hormone forces the baby into the cervix, which causes more stretching, which causes more oxytocin to be released, which causes the baby to be pushed further into the cervix. So this just keeps the cycle moving further along. Now we'll begin to turn our attention to specific glands and the hormones that they produce. And we'll begin our discussion with the hypothalamus. Now the hypothalamus is located just inferior to the thalamus within the brain, which is where it gets its name. So it's below the thalamus. The hypothalamus releases hormones that target another specific gland, which is the pituitary gland. The pituitary gland, in turn, releases a litany of hormones that have effects on other glands in the body. So it is the pituitary gland that is considered the master gland. The anterior portion of the pituitary gland is located within a carved out piece of bone in the sphenoid bone called the sella turcica. Sella turcica is a Latin word. It means the Turkish saddle. The little cutout in the bone where the gland rests looks like a if you're familiar with horseback riding, you know the difference between like Western and English saddles, the saddles that have the horn on them versus the saddles that do not have a horn on them. It looks more like the Turkish kind. It doesn't have a horn. Anyway, the anterior pituitary will release 6 specific hormones. And those 6 are thyroid stimulating hormone, and we're gonna be like the government, lots of words and lots of abbreviations. So thyroid stimulating hormone is known as TSH. One of the cool things about these hormone names, by the way, guys, is the name just kind of tells you what it does. So if someone says, what does thyroid stimulating hormone do? It stimulates the thyroid. That is what it does. By stimulating the thyroid, it encourages the thyroid to then do thyroid stuff, right? This just triggers the thyroid to do its thing. So we can say thyroid stimulating hormone stimulates the thyroid, and we are hunky-dory. That we are good enough with that. Mammary cells will, it triggers mammary glands to release a hormone called prolactin. Prolactin, like pro as in for, lact as in lactose, like milk. The prolactin hormone triggers the production of milk. So you can imagine only pregnant females are replete with the prolactin hormone, nobody else. Corticotropic cells will secrete adrenocorticotropic hormone. Side note, just want to throw this in here. You're about to see this word part a lot. I want to translate and give you a meaning with it so that we start to follow along. This word part, tropic, right? Tropic comes from a Greek word. It signals to turn or to change. So when we see the word tropic, what we're talking about is something that triggers change. So with this particular example, we are looking at adrenocorticotropic hormone, ACTH. Now let's break this name down. Adreno tells me the adrenal glands. So that is the first place where in our mind's GPS, that's where we go. First, we're in the adrenal glands, then cortico, or relating to the cortex. Remember, we talked about cortexes and medulla. The medulla is the meat of the orange. The cortex is the pith of the orange. So within the adrenal gland, the outer layer is making a list of hormones. The inner layer is making its own list of hormones. This hormone that we are talking about here, ACTH, is targeting the cortex, the outer layer. Tropic indicates to turn or to change. So it is triggering a change in the cortex of the adrenal gland. Follow me? What is it that is triggering this change? It is a hormone. So ACTH, what is its function? What does it do? It is a hormone that triggers a change in the cortex of the adrenal gland. See how we named that? Nice and pretty. Nice and pretty. I like it. So ACTH acts on the adrenal cortex. It triggers the release of stress hormones. Within other cells, we have human growth hormone, or HGH. This is commonly released all throughout childhood and puberty and adolescence. It is the hormone that triggers human growth. And the production of this hormone drops off in early adulthood, usually somewhere around the mid-20s, and it just constantly depletes as we age. We stop producing growth hormone as you age. Follicle stimulating hormone, or FSH, stimulates follicles within the genital region. Ladies, follicle stimulating hormone triggers the immature ova in the ovaries to become fertile. Usually only one egg per month gets the treatment, so only one egg per month becomes fertile. Men, follicle stimulating hormone triggers the precursors to sperm to become mature. So in either case, whether you're talking about male or females, follicle stimulating hormone triggers the maturation of our sex cells, the ovums and the sperms. Luteinizing hormone acts on the gonads, the testes, and the ovaries. It also has other sexual development functions. Another hormone is melanocyte stimulating hormone, or MSH. Melanocyte. Melano refers to melanin, the skin pigmentation. Cyte means cell. So a melanocyte stimulating hormone is a hormone that stimulates the cells that produce melanin. These cells become active in utero. They are responsible for the initial, when you are being developed, the initial flush of your skin tone. So if you are a darker skinned individual or a lighter skinned individual, this is what we're talking about. This happened like in utero. These melanocytes became active when you were still in your mom's belly, determining what your skin color would be. We are not talking about the kinds of changes that happen when you get a suntan or something like that, right? We're talking about your actual genetic permanent skin tones. Fun stuff.
So could you take that hormone and then permanently change your skin tone, or would it not affect you in your adult life?
My impression that is it's like a road. It's laid down once and it's done. That's my understanding. Unless you develop some kind of disorder or disease that would maybe destroy the melanocyte producing cells in your skin, there usually isn't a, well, I mean, skin bleaching is a thing. But that's damaging the cells intentionally to try to lower the skin tone. You don't see very many permanent skin darkening overall. Like tanning is temporary, but usually what people are trying to do is lighten their skin tone. But you do see disorders that will destroy skin tone, something like vitiligo. Vitiligo is a disease where it's not contagious. It just develops in your skin, but it resembles almost like somebody just poured bleach on the skin and it just took all the tone out. It's virtually albino skin. And it appears in random spots on the body. It's different for everybody, and it will just kind of slowly spread. That's the disease that they say that Michael Jackson had. Is why he just bleached his whole skin, just because he didn't want to be splotchy.
My son has that, and it shows up like randomly as he's growing. He'll get spots, and they'll get, like, when he was little, he had just like a couple small ones, and now as he's getting bigger, they're like much bigger patches where they were, and they just show up randomly. And his doctor was like, it happens. It's like nothing to be worried about. It's just going to continue to happen.
Yeah, it's not an infection. It's not a there's some debate whether or not it's an autoimmune disease, but it's not triggering inflammation in the body. It's just the cells that make melanin stop making melanin, and so you don't get any more skin pigment. But yeah, it's not contagious. And personally, I've seen some individuals that have, I mean, it's beautiful. It's very unique to have just these beautiful like sections of skin, almost like a calico cat. You know what I'm saying? Just how unique and individual and beautiful some of their splotches get. If you are not familiar with vitiligo, just do a Google search and check out some images. It's fascinating. So, okay, so this list of hormones that we've been talking about here, right? We've got the thyroid stimulating hormone, we've got prolactin, we talked about ACTH, we talked about human growth hormone, follicle stimulating hormone, melanocyte stimulating hormone. All of these hormones were being made in the anterior pituitary. So we're in the front half of the pituitary gland. Next, we're going to turn our attention to the posterior pituitary. And the posterior pituitary is unique from the anterior in that this one contains a little bit of neural tissue. We have some of those axon terminals extending down into this gland, using those receptors to detect things within the gland. So changes in blood chemistry and things of that nature, we're able to then go into the nervous system and trigger system-wide changes. So this is one of the many areas where the endocrine and the nervous system kind of directly interface here in the posterior pituitary. There are other areas like this. We will point them out as we get to them. The two primary hormones that are released from the pituitary gland are oxytocin and ADH, or antidiuretic hormone. Oxytocin is what we call the love hormone because it's responsible for all your sappy, mushy, lovey, shippy feelings. Oxytocin is released during orgasm. It is released when you hug your child. It is released when you pet your dog. It is released when you see friends. It is the hormone or the neurotransmitter, because it's the same thing in the brain as well, that is released when you have those warm, mushy, lovey, squishy feelings, right? Like puppies are so cute, you want to squish them, or babies are so cute, you want to bite their little toes, or you see somebody that you are very attracted to. All of these kinds of feelings of bonding, of attachment, of love and desire and connection. This is all due to the oxytocin hormone. Oxytocin also, fun fact, triggers the contraction of smooth muscle. So this is also the hormone that is triggering labor contractions. Same hormone. Antidiuretic hormone, if we could just change topics for a minute, has nothing to do with love or childbirth. It makes your kidneys retain water. So antidiuretic hormone stops you from peeing. Yeah, I know, we just like 180 degrees, but that's what it does. All right, that was really fun talk. Now, that was your pituitary gland. That was the master gland. It is the gland that is sending signals that regulates lots of other deals, right? One of the first hormones that we talked about was thyroid stimulating hormone. We're going to look deeper into the thyroid now. So, the thyroid. If you are not familiar with the thyroid is a nondescript, very unassuming, bow tie looking gland. And it sits, if I'll add the skeleton in so you can see, it sits right in the front of your throat. So just inferior to your larynx, to your voice box. So fellas, if you stick your 2 fingers on your Adam's apple and now go 2 fingers below that, that's roughly the location of your thyroid. It sits over the trachea. Let me add your respiratory system in there. So there you go. There's your voice box. There is the trachea. That is your windpipe. The thyroid gland sits just anterior to it, just in front of all that fun stuff. Now, the thyroid gland, oops, here we go. the thyroid gland secretes 3 main hormones, and they are neatly called T3, T4, and calcitonin. And if you want to take a wild guess as to what calcitonin starts to affect, anybody?
Potassium.
Potassium. Very close. So close. If you guessed calcium, does it have something to do with calcium? Yeah, you're on the right track. It's one of the cool things about hormones. So T3 has a really fun name. It's listed there in the little box on the slide, but I'll just write this out for you. T3 stands for triiodothyronine. So triiodothyronine. That's a really fun word to say. Tri means 3, and we are looking at thyronine, so T3. T4 is thyroxine. And these hormones primarily regulate metabolic rate, so how quickly your cells generally overall, like your whole body, how quickly are your cells burning energy, how quickly are they digesting, how quickly are they eliminating waste. We can either stoke the fires of the body and increase metabolism, or we can quench the fires of the body and lower the metabolism. So for example, we lower metabolism at night when we're sleeping. We don't really need to burn a bunch of stuff. When you go out and exercise and you get your heart rate up and you start sweating, we have increased our metabolism. T3 and T4 are responsible for those kinds of changes in the body. But they also have other effects, such as triggering the sympathetic nervous system response. So they trigger your Spider-Man fight or flight sympathetic system.
T4?
T3 and T4 together, both of them.
Okay.
Yes. T3 and T4 responsible for sympathetic function. Calcitonin helps regulate blood calcium levels. Now there's a slide here that says factors that affect thyroid function. This is going to dig a little bit more into like nutrition, kinds of nutrients that will benefit thyroid function. One of the more common, well, I don't want to say anymore because it rarely happens nowadays, but story time, fun fact. Years and years ago, I want to say it was like the early 1900s, I want to say like 1920, 1930, 1940, somewhere in that general era. There was a rash of thyroid conditions. People were developing a thyroid condition known as goiter. And if you've never heard of goiter or seen goiter, crap. It presents as a large swelling in the front of the throat. The thyroid gland becomes inflamed. There's a good example. So no, the distinct swelling in the fronts of the throats. This was happening all over the country. And what's happening is that the thyroid was suffering from a lack of an element known as iodine. You may have heard of iodine before, like if you've gotten a shot, they take that cold orange chemical and they swab it over the injection site, right? And it's that dark colored one. Iodine is important for the thyroid. It's required in order to produce certain hormones. So if we may pop back up here real quick, we saw the name of this triiodothyronine. Iodo, that's where that comes from. It's the iodine that is required in order to synthesize this hormone. So since the thyroid is lacking this the element that it needs to build this hormone, the thyroid is no longer able to function. So the thyroid becomes inflamed. You end up with this goiter, And it was an epidemic across the country. I mean, there were a lot of people ended up with this. And what they ended up doing to treat this as like a public health issue was they started putting iodine in the salt, in table salt. So if you've gone, and looked like bought large amounts of salt, right, and you see it says iodized salt, that's what they're talking about. Is they're simply saying we've added trace amounts of iodine into the salt. The trace amount is all you need in order to maintain proper thyroid function. So if you are not getting enough iodine in your diet, you should look at iodized salt. It is important for proper thyroid function, not the salt part, the iodized part. Another source of iodine is fresh fish, seafood, and things like that. You could also just take iodine supplements if you're a vegetarian. You could totally take iodine supplements. It's a mineral, so it's pulled out of the ground like iron or it's on the periodic table. So it's just, it exists out there in nature. You don't have to harvest animals for it. There you go.
Seaweed too, right?
Oh, I'm not sure. I don't think you're wrong. I don't know. Let's see. Good source of iodine. What foods are high in iodine? Fish such as cod, tuna, seaweed. Number 2. Awesome. Yeah, literally number 2 was seaweed. Shrimp and other seafood, which are generally rich in iodine. Dairy products like milk, yogurt, cheese, major sources of iodine, and iodized salt, which is readily available in the United States. So yeah, totally. Regardless of what kind of diet you may stick to, whether that's vegan, vegetarian, or what have you, there are plenty of acceptable ways to get iodine into your diet. Cool. Okay. So, along with your thyroid, there is a separate gland that is attached to it. So, yes, they share the same building, but no, they have different landlords, right? The thyroid on its posterior side has these 4 studs, and these guys are the parathyroid glands, the alongside the thyroid glands. Now, as we've seen with the endocrine system, just because they get their own name, that means they're going to get their own hormones to make, their own list of stuff to do. So they are doing a separate job from the thyroid itself. The parathyroid gland is responsible for secreting parathyroid hormone, or PTH, into the bloodstream, which increases blood calcium. Now, calcitonin decreased blood calcium. So what calcitonin causes is the calcium that is free floating in the blood, it triggers the osteoblasts in the skeletal system to pull mineral from the blood and lay it down in the bone matrix. That is the savings account. That is where we can store it and get it out of the blood, which returns your blood calcium levels to normal. What parathyroid hormone will do is trigger the release of calcium. So we trigger the osteoclasts, which break down bone tissue, releasing those minerals into the bloodstream, which raises the blood calcium level. Good stuff? All right. I know that was a lot. I know that was a lot. Go ahead, Zebedee. I'm sorry.
And where does that, from the bone, does that just pull it from the nearest like bone available, like in your neck or cervical area, or just from
the mechanism, I do not know, like exactly where, but what I will say is the effect is generalized over the body such that at a regular rate, your skeleton at a regular rate is slowly being reabsorbed and relaid down. This is how your bones just maintain themselves over the years. You may have heard from like pop science, you get a new skeleton every 7 years or something along those lines. About every 7 years or so is just going around the clock. about 7 years is about the amount of time it takes for the whole skeleton to undergo this process.
Oh, wow.
But it's a low rate, constant thing. Like a small amount of your bone is always being digested. A small amount of bone is always being laid down fresh. Hormones can increase or decrease that rate, but the process is ongoing. And about every 7 years or so, every piece of bone has been touched. Every piece of bone has been ripped up and laid back down.
Okay, one more question.
Yeah.
If someone has like a thyroid issue and they haven't like treated it in a long time, like haven't taken any medication, would that contribute to osteoporosis like over a long time, or?
So remember that every hormone, every gland, you know what I'm saying? It's all very conditional. But yes, I mean, what you're saying is not impossible. Yeah. If the thyroid condition is a condition where you're not producing enough of the hormone that lays down bone tissue, then yeah, you won't have enough bone tissue and you'll end up with osteoporosis, other types of brittle bone disease. You'll be far more prone to fractures. You'll be far more prone to things of that nature. Yeah. And the opposite is true as well. So people who their issue is that they are laying down too much bone tissue, they are prone to things like bone spurs, abnormal bone growths. This could affect the way that muscles are attaching to bone. This could affect the shape of bone, which when you're looking at spine, right, and vertebrae and how they have the discs and spinal cords and nerves poking around, abnormal bone growth can be a big, big problem when you're talking about bones growing near nerves or cartilage or joints and things like that. So yes, yeah, absolutely. Bones are regulated through hormones. So any problem with hormones could trigger a problem in whatever their target is. And throughout the endocrine system, you guys, that when we look at problems of the endocrine system, like pathologies of the endocrine system, those pathologies will generally fall into one of two main categories. Those are hyper and hypo. Either some hormone is being produced way too much, which is causing a problem, or some hormone is not being produced enough, which is causing some kind of problem. And I mean, that's whether you're talking about Graves' disease or Crohn's disease or, you know, lupus or, you know, or not lupus, I'm sorry. No, blanked out on me. But almost any endocrine disorder, like the fundamental issue is too much of a hormone or too little of a hormone. That's the crux of most of the diseases of this organ system. So these hormones are responsible for regulating the development and the maintenance of the skeleton. Hashimoto's. Thank you, Luke. Thank you, Luke. Yes. I knew it was one, but like as soon as I said lupus, I was like, no, that's autoimmune. That's the wrong system. Thanks, bro. Okay, so osteoblasts and osteoclasts. These are bone cells. These bone cells belong to the skeletal system. Their claim to fame with this section is that they respond to the hormone hotline, right? So they can pick up the phone and call for help or receive help. Blasts build. They build new bone tissue. They pull minerals from the blood and cement it down to make new bony layers. Clasts are the bone breakers. These are the ones that break it down, pulling the mineral from the bone. They pull it off in layers, they dissolve it, and they send those solutes into the bloodstream, which increases blood calcium levels, right? Both of these activities by these cells are regulated by either parathyroid hormone or calcitonin. All right. So this little cycle with the calcium that we just described, that same cycle is laid out here in the slideshow. And again, these get a little more technical, but This is another example of these kinds of feedback loops. So we begin with number one. If the calcium level rises above a certain point, then the thyroid gland, let's draw this out. So calcium increases beyond some threshold, right? This triggers the thyroid to release calcitonin. Calcitonin heads to the osteoblasts. We pull minerals out of the bone, out of the blood, lay them down onto the bone matrix. This causes the blood calcium level to drop. That is the function of the calcitonin. Now, one of two things will happen. Either it drops to a normal level, which means homeostasis is maintained, in which case we level it off. We're good, we're done, cycle's over, we're finished. Or maybe we keep going. And now the blood calcium level keeps falling and keeps falling and keeps falling. Now your blood calcium is too low. So the parathyroid triggers the release of parathyroid hormone. Parathyroid hormone triggers the osteoclasts. They rip up the fresh bone, they dissolve the materials, they send those solutes into the bloodstream. The effect is blood calcium rises. The blood calcium level will continue to rise until either we hit homeostasis, in which case we wrap it up, we're done, we're good, we stop, process over, or we keep right on going, in which case now our blood calcium level is too high and we trigger the whole process over again, right? Blood calcium level is too high. So the thyroid gland triggers the release of calcitonin. This causes the osteoblasts, on and on and on. And the same cycle repeats itself, either until homeostasis is maintained, or we just keep going on and on forever. Now, for most healthy individuals, homeostasis will be maintained. So all we need are small little tweaks up and down here and there. Like when you're driving on the interstate, you only need to turn the steering wheel a small amount just to keep in your lane. You don't really have to do a whole bunch of crazy stuff. What happens when your hormones have to do a whole bunch of crazy stuff? You've got some kind of disease, right? We're having to compensate for something like that.
I have one more question. You're not able to live without your thyroid, right?
I think you can. They can give you medications that will simulate the functions of a lot of hormones. But I mean, it wouldn't be ideal, but I'm sure you could. Okay, so the next gland we're going to look at are the adrenal glands. Now your adrenal glands are these two yellowish kind of pyramid shaped glands. And these guys are located sitting on top of each kidney. It reminds me of that band Devo. You remember from the 80s, they had those weird like red hats and they sang that song, "When a Problem Comes Along."
Oh my God, it does look like that.
Right, right. So they've got these dorky little hats, right? And your kidneys are singing their stupid little song, right? Because they got to pee all the time. But these adrenal glands are actually rather interesting. So that's not what I want to do. I want to, can I fade? No. Let me see if I can cut the adrenal gland. Suprarenal gland. Boom. Got it. Awesome. Okay, my computer's lagging. Give me a second. There we go. All right. So we've just taken a little slice of your adrenal gland, right? The adrenal glands, remember, these are the guys responsible for your fight or flight response. These are the guys that make adrenaline and cortisol. These are the guys that make the hormones that send you into panic mode, right? You got two of them. They sit on top of each kidney. Now we're going to take that gland, we're going to take a slice of it, and we're going to cut it open and look into it. and it kind of looks like an orange slice. You know what I mean? Right? Doesn't it kind of look like a piece of fruit or something that you would cut into, like a segment of an orange or something like that? So along the outside, right, you have the skin of this gland. This would be called the capsule. The capsule, a pineapple. Yeah, like a piece of pineapple, Travis. So the capsule is like the skin of the pineapple. You don't really eat it. It doesn't really do anything. If we're really going to get into the functions of this thing, we're going to want to peel the skin off. There we go. So this outer portion is the cortex. So this is the outer layer. So again, if we're thinking about an orange, seems to be a better idea here. So with an orange, think about the actual orange portion of the fruit on the outside, right? Anyone who cooks, this is the part that you would take off when you zest the orange, right? You zest the orange, you're just taking off little bits of the orange coating, but there's still the white coating remaining on the fruit, right? The white portion would be analogous to this cortex. That is the outer layer that is responsible for something. Now, once you peel back the white rind of the orange and you get to the fruit of the orange, the part that you actually eat, now we are down in the portion called the medulla. And the medulla is the central portion. So we see this pair of words, medulla and cortex. We see it over and over and over again throughout the body. You've got, in the skeletal system, you had your medullary cavity in the shaft of the bone. And then the outer layer of bone, the hard, compact bone, was also called cortical bone. Cortical related to the cortex, the outer layer. So the cerebral cortex, the outer layer of the cerebrum, versus the cerebral medulla. We see this pairing over and over again. Medulla is the meat, cortex is the rind, and then the capsule would be just the inedible skin of the fruit that we don't usually use, right? Good stuff, fun stuff. Now, I spend so much time drawing that distinction because the cortex and the medulla produce different hormones. They do different things. So within our adrenal glands, the adrenal cortex, the outer layer, produces 3 hormones. Those are aldosterone, cortisol, and steroid sex hormones. So aldosterones and other mineralocorticoids, when you hear that word mineralo, think minerals, you're thinking about things that affect minerals in the blood, like potassium, the amounts of water retention, sodium, which helps regulate blood pressure and things of that nature. This aldosterone, these mineralocorticoids, they're responsible for regulating the amounts of minerals in the blood. Cortisol, this is one we've heard before, that's a stress hormone, right? Cortisol and adrenaline go together. Your steroid sex hormones, steroids are lipid-based, which means they're able to be taken directly through the cell membrane and right into the cell. That is what defines steroids. Now, steroid sex hormones are simply chemicals that are lipid-based, that are active within the sex glands. They control reproductive function and sexual development. The medulla, medicinal corticosteroids will mimic the actions of steroids that are produced by your adrenal glands. So let's say maybe you've got a disease where your adrenal glands are underactive. We can give you synthetic hormones, right? Like hormone replacement therapy or things like that. Let's say you're low in calcitonin. right? You're developing, like Zebedee asked earlier, you're developing osteoporosis because your body isn't producing enough of the hormone. We can give you a synthetic hormone. So some hormones can have their effects mimicked. Doctors can also prescribe corticosteroids to reduce inflammation, because that is what cortisol does in the short term, is that it reduces inflammation. So if you're talking about inflammatory conditions like Crohn's disease or ulcerative colitis, multiple sclerosis, lupus, rheumatoid arthritis, all of these are chronic inflammatory diseases. Prescribed corticosteroids will reduce the inflammation. But cortisol reduces inflammation in the short term. In the long term, cortisol has some rather detrimental effects. Being a stress hormone, remember, when the body goes into fight or flight, one of the things that happened was digestion virtually stops, right? We shut down our digestion. So if you are taking corticosteroids, you are constantly introducing cortisol into the body. It is constantly going to lower your digestive ability. And when you cannot digest your food, your body will store your food for later. Food is stored as fat. Therefore, prolonged amounts of stress, prolonged amounts of exposure to cortisol, prolonged prescriptions and takings of corticosteroids can lead to weight gain, because it dampens your digestive function. And when your digestion becomes dampened, we just store everything as fat. This can also lead to decreased muscle tone and increased body hair. Now, we are not talking about like a human gorilla type of thing. We are just talking about the normal hair that just grows a lot more. Ladies, we do not shave our face. We know those little delicate, little clear type hairs that grow along your jawline, right? You ever seen ladies that have those kinds of hairs, but those hairs are darker and it looks almost like a very fine, thin beard, but those hairs are not thick and whiskery, right? They're fine and delicate, dark hairs. That's the kind of hair that we're talking about. Prolonged taking of corticosteroids just leads to increased body hair growth. We're not talking about anything freakish. We're just talking about your normal body hair just grows more. That's all. Now, looking now at the adrenal medulla, your medulla is located on the inner layer of the adrenal gland. So as we said, the medulla is the core portion of the gland, right? The central portion, the meat of the orange. It produces epinephrine and norepinephrine, also known as adrenaline and noradrenaline. I know that these words only have one like little prefix off from each other, but they are separate chemicals, right? Adrenaline and noradrenaline. Adrenaline and noradrenaline act on the sympathetic nervous system. They respond by triggering the fight or flight response. They activate smooth and cardiac muscle. Cardiac muscle increases your heart rate. Smooth muscle shunts the blood away from the digestive organs out towards the skeletal muscles. And it increases the actions of glands to secrete other hormones that we need to help, keep us safe, fight or flight. The adrenal medulla releases hormones that are responsible for increasing heart rate, blood pressure, and blood glucose. If we need to run from a bear, then our muscles need a lot of energy. So we increase our blood sugar by releasing a lot of glucose so that your cells have a lot of quick burning energy readily available to them so that we can fuel the muscle contractions needed to run away from the bear or whatever it is that has you in fight or flight mode. Small point I would like to make, since we are talking about epinephrine, which is also known as adrenaline. Adrenaline is made by the medulla. Cortisol was made by the cortex. So when we consider the adrenal glands, the two most famous hormones that they release are adrenaline and cortisol. I would just like to point out that adrenaline and cortisol are made in separate areas of the adrenal glands, the medulla and the cortex respectively. All right. Good stuff, guys. Any questions over what we've covered so far? All right, let's take a break. Let's take 15 minutes. It is 2:40 right now, so we will come back at 2:55 and we will wrap up the endocrine system. I know on the weekly syllabus and on Moodle it says that we're going to wrap up endocrine and then pick it up next week. When we come back from break, we'll see how we feel, but we don't have that much left to go when I looked over all the PowerPoints. So we'll see how we feel when we come back from break. All right, let's take 15. I'll see you guys back at 2:55. Good stuff. All right, everyone, we are back. And I added into the chat just some clarification, just to make sure that we're all on the same page about positive and negative feedback loops, as well as hormones and neurotransmitters. These were just nothing special. I just pulled these off Wikipedia. I just thought they just kind of crystallized the questions that usually arise between these two. I just want to make sure that we had something in text that we could read and clarify those. All right. So now that we have had a chance to kind of decompress from what we have just endured, how are we feeling about this material so far? Questions? Anything we want to clarify? Sorry, guys, one at a time. I can only hear one at a time.
I'm feeling good. I just need to spend more time with the material.
Okay.
For the anterior and posterior pituitary gland, are we able to see that on the complete anatomy?
Yes. So this will take me a moment to kind of like, I got to carve my way into it. Okay. So just bear with me, but you know, enjoy the visuals as we make our way there. So there is a portion of the pituitary. We've divided it kind of left and right, but remember the pituitary itself is divided anterior and posterior. So here you can see the way it really just sticks out and dangles down, almost like an anglerfish deal. I'm looking currently, I'm digging around, I'm looking for the hypothalamus. That is what I'm searching for. I have the anterior nuclei of the thalamus, but I still don't think I'm quite there yet. Let's see if I can search for it. Ah, there it is. Ah, cool, thanks. Go away. Go away. There's the hypothalamus. There in green. So as you can see, it is quite well buried. But there's the hypothalamus and the pituitary. And let's see if I can dig into the pituitary at all. Nope. Oops. There. So what I will add in is the skeletal system. So as we hide the bones, there you can see how the pituitary just rests in that little bony carve out. So to give some perspective to all of this, I'm going to remove the whole nervous system and we're just going to look at the bones. So when you look down inside the skull, we're going to remove your parietal bone. Oops. So now as you're looking at, we're missing the left temporal bone. I didn't mean to hide that one. Sorry. There. So when you remove the parietal bones, you look down inside of the skull. There is the sella turcica, this little groove. This is where your pituitary gland sits. Now, I've held skulls in my hand, and when you stick your finger down into it, it's that little depression is just about large enough for the tip of your index finger. I mean, that's about the size of it. Good stuff. Yeah.
Yeah.
Unfortunately, if I add in, and trigger warning, you guys, the model here is a male. Sorry about that. But when I add in the endocrine system, that's what it gives me. So I only have thalamus or thyroid and parathyroid. I get the adrenals and the pancreas and testes because they're gonads. And get female. When I add my female pelvis, I can get urogenital, but it doesn't give me endocrine. But I can see ovaries there. Yeah. But that's all it gives me. So it's a little difficult to pull up the pituitary and whatnot. You really just kind of got to dig your way in through the brain to get to it on this app. But I'll take what I can get, you know, it's worth it. Still worth it. All right. So what do you say we do a quick recap? Quick little review of the stuff we've covered. Just a nice little summary. Just a little summary. All right, get the pencil. So we'll go back up to the top. And I'll change my color so we know we mean business. How about yellow?
I really like the screen setup this week so that we can like see the slides and have you writing at the same time.
Thanks. You know, I've been teaching a while, but not teaching online for a while, so I'm learning as I go. So getting better. It's getting better. It's getting better. All right. So we got a new color. So we got a new section. So endocrine system, we generally divide into exo and endocrine glands. Exo means outside, right? So my Star Trek fans in the house, I know you're out there. Remember the Department of Exobiology, right? It's when they study animals on other planets, right? Like Vulcan critters and whatnot. So exo means outside. So exocrine glands are secreting to the outside, either to outside the skin or inside a body cavity, like inside the mouth, but that's still outside the body. Feel me? Like it's still the outside world. And they do this by using ducts, tubes. They squirt their stuff through a tube and it goes to the outside. Endocrine glands, on the other hand, no ducts. They squirt their secretions, their hormones, directly into either the bloodstream or into the interstitial fluid, which then those chemicals will then diffuse into the bloodstream from the interstitial fluid. So either way, they are not squirting through a tube. They just squirt it outside the cell, and there it is. Into the bloodstream. I know that's terrible. That's supposed to say into the bloodstream. Sorry. Okay. So what do? They produce hormones. Which are chemical messengers. These are chemicals, actual molecules. Molecules usually made of amino acids. When amino acids are linked together in particular ways, they are also called proteins. And welcome to anatomy. Everything has 5 different names. Chains of amino acids are also called proteins, are also called peptides, also called polypeptides. Same stuff. You're just talking about chains and chains and chains of amino acids, all strung together in really special ways. When we say strung together in special way, sorry. When we say strung together in special ways, let me just protein shapes. You guys ever seen those biology textbooks and they got crap that looks like that in it? This is what we are really talking about. They are strung together, and because of their actual 3-dimensional shape, they either bind to something or they do not bind to something. It is literally like a key and a lock. It has to be physically shaped the correct way in order to bind or unbind with some kind of receptor in the body. Hormones are the exact same. I mean, this is exactly how they work. There is very little difference in the actual chemical, whether we are talking about hormones or neurotransmitters. The big difference is where we find them, what cell makes them. The chemicals themselves are pretty much the same. Like adrenaline and epinephrine and norepinephrine, pretty much the same chemical. The difference is they're made in 2 different places, they operate in 2 different places, but the chemical itself is pretty much the same. It's shaped pretty much the same. We use the same shaped receptors on the cells, whether you're talking about a postsynaptic neuron or you're talking about an endocrine target cell. Good stuff. Good stuff. So hormones are chemicals. They can be made of amino acids, which are proteins. They can be made of lipids, which are steroids. And we release these hormones to go on to affect some target cell. The target cell is a cell that recognizes a hormone and responds to it. So it's got that very fancy shaped receptor that fits onto that very fancy chemical, and only the cells that have that particular receptor will respond to that hormone. So your lung cells, for example, do not respond to the signals that tell the menstrual cycle to start. Lungs have nothing to do with that. They don't even hear the message. They don't get it. It has nothing to do with them. So target cells are the ones that have the special receptors. They get responded to. Hormone receptors, we just explained this. Hormone receptors, the very special fancy lock that the hormone fits into. The effects of the hormones will depend on the concentration of the hormone, so how much hormone is present, the quantity of the receptors, how many receptors does the cell have? The more receptors, the more strongly it can respond, and the affinity of the receptors for those hormones, which can be affected by a lot of different things. Men, as you age, right? And fortunately for us, it really starts happening later on, right? And when you in like proper old age, when you're talking about like 70s and older, as your testosterone levels start to wane, your testosterone receptors start to become less sensitive. So even though you may be producing testosterone, your body may not actually be able to bind and receive the testosterone. It can, it's just to a diminished capacity, for an example. All right, 3 types of stimuli that trigger hormone release. Right, so we've got our various types of glands that release hormones. What triggers the release of hormones? It is either going to be that it's supposed to be a thermometer. Hold on. Bah. I'm going to draw a little thermometer here because we are looking at chemical concentration, or we are looking at a neuron stimulus, or we are looking at some other hormone. That was definitely supposed to be a round flask with an H on it. So hormones, neurons, or chemical concentration changes. These are the things that trigger the release of hormones in the body. These operate based on feedback loops. And we will use either positive feedback loops or negative feedback loops. Positive feedback loops will act to increase the stimulus that caused the release of the hormone. So the text that I put into our chat earlier, positive feedback loops enhance or amplify changes. This tends to move a system away from its equilibrium state and make it more unstable. So positive feedback loops, if we are approaching some threshold, positive feedback loops will tend to accelerate, taking us further away from equilibrium. Negative feedback loops, on the other hand, when we are approaching some threshold, they will tend to reverse the stimulus and bring us back into, well, I'll show you up here, bring us back towards equilibrium. Negative feedbacks tend to dampen or buffer changes, which holds a system to some equilibrium state, making it more unstable. So the way these 2 feedback loops will work together, right? If you were taking some reading, and here's our little scale, and here is our arbitrary, this is where we want to be, is this dotted line in the middle. And we've been holding on perfectly, but we start to get too much of something. Let's just say blood calcium. Blood calcium starts to get too high, so we trigger a negative feedback loop, which starts to bring it back down to normal. But now we get too far down, so we trigger a positive feedback loop. But now we trigger a negative feedback loop. Over time, over the course of a day, as these hormones continue to try to balance each other out, the overall average is that we stay somewhere around equilibrium. Sure, we may have short spikes where we go above or below, but the system is always working to correct itself and to balance everything out, right? The system goes haywire when we maintain a level above or below some threshold, this is why we say most of the diseases that are associated with the endocrine system are diseases of either hypothyroidism, or I'm sorry, hyper or hypo. So hypothyroidism, hyperthyroidism. Some hormone is either being overproduced and has a bunch of effects, or it is being underproduced and that has a bunch of effects. Good stuff so far. Cool. So the hypothalamus, located in the brain, connects to your pituitary gland. Stimulates the anterior pituitary. So our anterior and posterior pituitaries, we have the thyroid stimulating hormone, which stimulates the thyroid to do thyroid stuff. We have the adrenocorticotropic hormone. Tropic, we said, means to turn or to change. It's from a Greek word. This is the same word that we get the word tropic from, like the tropics, where the weather changes rapidly, right? So tropic hormones tend to trigger changes. This particular hormone, tropic hormone, triggering changes in the cortex of the adrenals. ACTH. We have luteinizing hormone, follicle stimulating hormone, prolactin, and growth hormone, all produced in the anterior pituitary. Posterior pituitary, we have oxytocin, which is the love hormone. Birth, love, orgasm, connection, all the kinds of things, all the things. And antidiuretic hormone, which tells your body to retain water, so you stop peeing. There you go. Your thyroid produces 3 primary hormones. Those are T3 and T4. I'm not sure if you'll need to know them or not. Yeah, random combo. I didn't design the system, man. I mean, could you at least put them in alphabetical order? I mean, come on, throw me a bone here. I mean, T3, T4, and calcitonin. So T3 is triiodothyronine and thyroxine. T3 and T4 primarily balance metabolic rate, just keep your body burning. So when you think about someone with hyperthyroidism, right, their body is overactive, they have a lot of energy, they can't sleep, they keep going and going until they're drained, but they still can't sleep, right? Hyperthyroidism. People with hypothyroidism tend to be more lethargic. They can't summon the energy. They tend to become overweight because their body just keeps storing food. Their metabolism is depressed. So it's an issue with the thyroid is these hormones are not in balance. So we're not able to maintain homeostasis. Calcitonin plays a key role in calcium homeostasis. We said that calcitonin reduces blood calcium by triggering osteoblasts to pull the minerals out of the blood and lay it down as fresh bone matrix. So lowers calcium in the blood. Next, we have parathyroid. So the parathyroid is located on the posterior aspect of your thyroid. So if the thyroid is looks like a little bow tie at the bottom of your throat down here, the parathyroid are just those 4 little beans sitting on the little back of your bow tie. Parathyroid secretes parathyroid hormone. You guys may also hear this. I don't know. Sometimes it's called this. You may hear it called sometimes parathormone. It's the same. It's parathyroid hormone or parathormone or PTH. We're talking about the same stuff. The last textbook that I was teaching anatomy out of referred to the hormone in this way. Parathyroid glands produce parathormone. The function of this is the opposite of calcitonin. Parathormone triggers osteoclasts to break down old bone material and release those minerals into the bloodstream, which increases free calcium in the blood. So your thyroid and parathyroid glands are responsible for maintaining the homeostasis within the bone matrix, which keeps your skeleton refreshing at a constant rate. So generally, older bone will be broken down, fresh bone will be laid in, and you'll get a brand new skeleton about every 7 years or so. It's a slow and steady process with bone, man. Nothing fast ever happens in the bone world. Except fractures, and those are bad. All right. Here we simply have an illustration of the feedback loops that go on with the bone, the laying down of bone minerals. So your thyroid and parathyroid glands releasing, it's just a visual of the cycle. Adrenal glands. We have the cortex and medulla. The cortex would be the, actually, hold on, I want to move this down a little bit. Okay, so the capsule, we would say, is more like the skin of the orange. The cortex is more like the white rind of the orange, and the medulla is the fleshy meat of the orange, like the part that you actually eat. So the capsule is just the outer layer. It has got blood vessels and stuff, but it doesn't do anything. Like it protects it, you know, kind of whatever, but like it doesn't produce hormones. It's not really functioning in that manner. It's just the skin of this particular organ. That's what it does. Cortex, on the other hand, produces, you know, a variety of hormones. 3, aldosterone, and various other mineralocorticoids. Mineralocorticoids regulate mineral balance in the blood. So magnesium, sodium, calcium, right? The amounts of the minerals that are floating around, if they get too high or too low, this guy deals with that and regulates those. We have cortisol and other glucocorticoids. These are triggered in stress response. That's the cortisol that's released during fight or flight. And steroid sex hormones. These are reproductive function, sexual development. The adrenal medulla produces epinephrine, which is also called adrenaline, and norepinephrine, which is also called noradrenaline. These adrenalines trigger fight or flight, and they activate smooth and cardiac muscles within the glands. So this is what triggers the flow of blood away from the digestive organs out towards the skeletal muscles, increases heart rate, blood pressure, increases the availability of blood glucose. So your cells have sugars floating around in the blood, which is very quick available. They can burn sugars very quickly for energy. So we make a lot of energy readily available to them. So your muscles have all the sugar they need to burn so they can keep running away from a bear or whatever the stressful response is. Folks, that is everything we have covered thus far. How are we feeling? Pretty good.
I have another question.
Of course.
All right. When we drink like coffee or any type of caffeine, does the caffeine go into our blood system? Or also I've heard possibly that the caffeine has something to do with our cortisol. Is that right? Like it makes...
I don't know how caffeine affects cortisol. I know that it is a drug, it's a stimulant, and all stimulants affect the central nervous system, increases heart rate.
Oh, okay.
But I'm not sure.
All right,
Caffeine is known to increase alertness, insomnia. Yeah, high blood pressure, rapid heart rate. So if it's creating changes like blood pressure, heart rate, it's affecting the central nervous system.
Okay, the central nervous system, not really so, like your...
Now, I don't know like the chemistry of how that happens. I trust that they know how it happens.
Yeah. Okay. Also, one other question that I thought of, do hormones affect your circadian rhythm or sleep and wake cycle?
Oh, yeah. Oh, yeah. I've been hesitant to... When we came back from break today, I really wanted to gauge how you guys were doing because this is the PowerPoint for this week. Next week, we continue the endocrine system and we have more glands and more hormones to learn, including the pineal gland. And that's the one that touches on what you're talking about, that monitors circadian rhythm and your sleep-wake cycles and things like that. So we are not done yet with the endocrine system. What I was trying to gauge is, are we done for this week? Is this enough material to last us until next week? Because we've got more glands and more hormones and male reproductive system next week. So continue endocrine and male reproductive system. That's the plan. So part of me feels like we could just keep right on going. Yeah. But the other part of me is like, this is a lot of stuff to memorize. This is quite a bit of stuff. So I feel like we're pretty good. Yeah.
Just take it in. Yeah.
It is a lot. And like I said, I wish there was a rhyme or a reason. I wish I had some fancy like, on Olympus, towering tops. Here's how you learn all the hormones in your brain. But no. I do have, however, a Kahoot for the endocrine system. Are you guys familiar with Kahoot? Yes.
Oh yeah.
I see yeses and I see nos. So if you guys who know about Kahoot, just bear with me for the people who have no clue what the hell I'm talking about here. Kahoot is an online quiz type game. Despite all the payment options, it is free. You do not need to pay anything. Do not give them your money. Just create a free account. You can play all the games you want. Come on. Okay, so my username is DH_OSM. So if you go to Kahoot and you search for my username, you will be able to find all the Kahoots that I have made. Now, I know I'm new to OSM, but you guys have been teaching for a long time. So I have made whoops, come on. All this zooming and anatomy app and all this stuff is pushing my poor iPad to the limit, man. My poor iPad's just about had it. Where is like my Kahoots? Ah, here we go. 36 Kahoots I've made. Okay, so the deal with Kahoots is you have, they're multiple choice or true false type questions. You go through one question at a time. You're not timed, but you get more points the faster you answer. So you want to answer first or quickly. You can play these games by yourself, or if you have a study group, you all put in the same like room code or whatever that it'll give you, and you can all play together. It'll show you the same question and everything. And then you get ranked, you know, the person who answers the most correct or, you know, the fastest and stuff. It's really, really fun. But I have, so for example, organ massage law. I made a 23 question Kahoot about organ massage law. So there you go. Have fun with that. If you guys are taking other classes, there's probably a Kahoot in here that could help you with something like that. Just take a look and see what's in here. But for us, so my last school grouped these organ systems together. So I'm gonna have to go in here and kind of pull them apart into separate Kahoots. But thank you, Kahoot. Go, geez, man. Okay, these pop-ups. So here is my endocrine, urinary, and reproductive system Kahoot. And so you've got questions like, what are specialized organs that vary in size and function? And those are glands. And you have two main classifications of glands are endocrine and exocrine. Just a cool way to review. I do need to pull the other stuff out of here so that it's more relevant to our class, and it doesn't include like the urinary and reproductive stuff, but I'll get there. So, whew. Okay. So, unless we have any questions, my inclination is to simply turn around and go through this again. All right, let's do it. I hope you guys were taking notes.
And then with the endocrine system, there's basically 4 different areas of the body. So you have the pituitary gland, the thyroid gland, the adrenal glands, and the ovaries and or testicles. And then and then no kidneys, just adrenal glands.
Pancreas.
Yeah. As you can see, we still have a lot more still to cover next week with the endocrine system. So, okay. Who can tell me what were the 2 main divisions of the endocrine system? 2 main types of glands we find in the system.
Endocrine and exocrine.
Very good. Endocrine and exocrine. What's special about exocrine glands?
They have ducts to secrete to the surface versus
They have ducts. They secrete to the surface. Very good. Give us some examples. Give us some examples
Tears,
of exocrine glands.
saliva, sweat.
Tears, sweat. What else did you say?
Saliva.
Saliva. Milk glands, mammary glands. Very good. How about endocrine glands?
They're ductless.
Ductless. Where do they do their secretions into?
The bloodstream.
Very good. Secrete into the bloodstream. Okay. So they are secreting hormones. What are hormones specifically?
chemicals, basically.
Chemicals. And what 3 things can hormones be made from?
Amino acids, proteins.
And polypeptides.
Yeah.
Fats, lipids.
Steroids.
So how do hormones work? What's the story?
They are a chemical messenger that travels through the bloodstream
Mhm.
from an endocrine gland to a target cell.
And what happens when they reach the target cell?
They bind to a specific receptor, kind of like a specific key to a specific lock.
Yep.
So bind to receptors based on their physical shape. Very good. And where are these receptors found?
On the membrane or in the nucleus of the target cell.
Very good. Very good. So, guys, when we talked about our amino acid type hormones, these guys have to dock on the surface of the membrane. They need a membrane receptor. The steroids, which are lipid based, remember the membrane of your cell is a phospholipid bilayer. It's made of a layer of fats. Since these kinds of hormones are also made of fats, they're able to just slip right through the membrane. So those are the kinds that can go into the cell without any, they can just go right through the membrane, and then they dock within the nucleus or other receptors that are just found inside the cell. There you go. Good stuff. So receptors are on the membrane, or they are located inside the cell, sometimes in the nucleus. And then once they are received by the cell, then what happens? What happens when a cell receives a hormone?
Causing a change in the target cell, protein synthesis, enzyme activity, membrane permeability, and cell reproduction happens. I took too many notes today.
It's okay. Lots of notes are good. So the binding of this hormone triggers some kind of change, either in the cell's functioning, right, in the rate of metabolism or what it's making, right, its rate of protein synthesis, or in the cell's behavior. So it makes its membrane more permeable or something along those lines. Very good. What are the 3 ways that hormones are triggered?
Chemical concentration,
Or a specific substance in the body's fluids, like blood sugar or O2 levels.
Excellent.
There's 3.
And the third?
Yeah. Secretion simulated by a nerve impulse neural, example, adrenaline.
Very good. So we can produce hormones because we received a stimulus from another gland, right? Like the master gland told us to make more thyroid stimulating hormone. So the thyroid makes more thyroid stimulating hormone. There's example of number 1. Number 2, chemical concentrations. So the thyroid releasing calcitonin in order to lower the blood calcium levels, right? It released a hormone in response to a chemical change, a change in the concentration. Or the release of adrenaline triggered by an action potential coming from a neuron. There is a nervous system impulse that triggers the release of a hormone. Very, very good. All right. Feedback loops. What is the difference between positive and negative feedback loops?
Positive feedback loops just continue to increase, whereas negative ones increase to your spot and then decrease.
Very good. All right, hypothalamus. Where is the hypothalamus located?
Below the thalamus.
Below the thalamus. Very good. Which gland does the hypothalamus target?
The anterior pituitary.
Very good. All right. Where is the anterior pituitary gland located? Well, pituitary altogether, the whole thing. Where's the pituitary located?
At the stella turcica.
At the sella turcica, which is located on which bone?
Ethmoid? Sphenoid.
Sphenoid. And which hormones are released by the anterior pituitary?
Oxytocin and ADH.
That is the posterior pituitary.
Thyroid stimulating hormone.
Good. Thyroid stimulating hormone. And what does thyroid stimulating hormone do?
Stimulates the thyroid.
Very good. What else do we have? What other hormones are released by the A pituitary?
There's ACTH.
ACTH. What does
And
ACTH do?
It stimulates the cortisol or something, right?
Yeah.
There's too
Yeah.
much. It,
Produces cortisol.
oh yeah. But it turns and changes. That's the tropic part, remember? So I'd have polypeptide tropic hormone produce secreted APG.
Okay. So ACTH is a hormone, which is a tropic hormone, which means it triggers some kind of change. In the cortex, in the outer layer, the rind of the adrenal gland. Now, when we ask ourselves, what does the cortex of the adrenal gland produce? Cortisol. It makes cortisol. So the release of ACTH triggers the release of cortisol. But that particular C stands for cortico, related to the cortex of the adrenals, where the cortisol is produced. So we have ACTH. What other hormones do we have? I believe there were 6 in total.
Luteinizing hormone.
Luteinizing hormone. What did luteinizing hormone do?
They, it's something with the testes and the ovaries.
Very good. Something with the testes and the ovaries. Yes. What else do we have?
Prolactin.
prolactin. What does prolactin do?
Production of milk.
Production of milk. Very good. Give me another one.
Human growth hormone.
Human growth hormone. What does human growth hormone do? If you say it makes humans grow, you get bonus points.
Children grow.
Yes, yes. Human growth hormone makes humans grow. Very good. And one more. There's one more we're missing.
Follicle stimulating hormone.
That's the one. Follicle stimulating hormone. What does follicle stimulating hormone do?
It triggers immature ovum to mature and get ready for pregnancy.
Very good. Very good. Follicle stimulating hormone will affect usually one ovum per month. One egg ripens every month and gets ready to get fertilized. And if it doesn't get fertilized, then it gets flushed. Follicle stimulating hormone does a similar thing in men. It quote unquote ripens a batch of sperm. So they all, get their tails screwed in. I'm kidding, but effectively I'm correct. They don't really screw in the tails though. Okay, so after the anterior pituitary, we have the posterior pituitary. Now this one is located, it's the same gland, you're just looking at two different lobes of the same little bungling cord. So it is still located in the sella turcica of the sphenoid bone. Dexter, can you tell us one more time which hormones are secreted by the posterior pituitary?
Gladly. It's my time to shine. Oxytocin and ADH.
Very good. Can you tell us what those two hormones do?
Oxytocin is involved with breastfeeding, empathy, trust, sexual activity, relationship building, and then ADH is for conserving fluid volume of your body's water by reducing water pass out of the urine. I kind of messed up that last one. My bad.
No, you nailed it. Yeah, that's exactly correct. Very good. Very good. That's exactly right. Oxytocin we call the love hormone because it's involved in all sorts of bonding, whether you're talking about bonds with your pets or your kids or your lover or your friends. It's that bonding. I don't know how else to put that. Bonding. And ADH retains water, keeps you from peeing. All right, so we've got anterior pituitary, we've got posterior pituitary. Next up, we have thyroid. So, where is your thyroid and what does he do?
It's located in your neck.
In the neck. What's it shaped like?
Shaped like a little bow tie.
Little bow tie, yeah. And there are 3 hormones released by the thyroid.
T3, T4, and calcitonin.
Fantastic. What is the full name of T3?
Triiodorothyronine.
You gave that a really good attempt.
I tried.
It shows. You did a good job.
Triiodothyronine.
Triiodothyronine. That's a fun one to say.
Because it's composed of iodine. I forgot about that.
Yes, there's iodine involved in its manufacture. So, triiodothyronine. T4 is known as thyroxine. And what are these 2 hormones responsible for? What do they regulate?
They affect the metabolism.
Good. And what does calcitonin do?
Regulates calcium levels in the bloodstream.
How does it regulate them?
It lowers
Very good. It lowers blood calcium level. That's supposed to be enough. Lowers blood calcium. Very good. Where is the parathyroid gland located?
Posterior to the thyroid.
Excellent. What does it look like?
4 little bumps on the back of the thyroid.
Very good. Just 4 little bumps on the backside, posterior side of the thyroid. The parathyroid gland produces one hormone primarily. What is the name of its hormone? Please don't overthink this one.
Parathyroid hormone.
Parathyroid hormone. Thank you. Do not overthink this stuff. Parathyroid hormone, also known as parathyroid hormone or parathormone or PTH. Same stuff. Same stuff. Different name, same stuff. Welcome to anatomy. What is the function of parathormone? What does it do?
Increases blood calcium.
Fantastic. Raises blood calcium. Fantastic. All right, your adrenals. We have 2 glands going on in the adrenals because we've got separate hormones being produced in different sections. What are the 2 active sections of the adrenal glands? Go.
Cortex and medulla.
Cortex and medulla. Which hormones are produced by the cortex?
Cortisol, steroid sex hormone, and aldostero. I don't know. Aldos. I don't know what I wrote to tell me again.
Is
Mineral
aldosterone?
fluiditis.
Emphasis on the DOS. Aldosterone. Say it with us. Aldosterone.
Aldosterone.
Fantastic. So, aldosterones are categories of mineralocorticoids. Mineralocorticoids regulate minerals. So we're talking about potassium, sodium, we're talking about chlorine, we're talking about all those minerals floating around, iodine, all those random minerals roaming around the body. Very good. What about the medulla? What hormones are secreted here? Well, we've got cortisol over here. What goes with cortisol, guys?
I'm gonna say adrenaline.
I didn't catch that.
Adrenaline and noradrenaline.
Very good. Very good.
And this is where we stop because we don't go into the pineal, which is a part of the endocrine, and then melatonin and all of that now, right?
Correct. This is the end of the week 6 PowerPoint. So when we go to Moodle, if you look at week 6, it says slides to fill out your notes part 1, slides to fill out your note, slides to fill out your notes part 2. We've only gone through part 1. The way that this was set up was week 7, next week, we finish the endocrine system. That would be the part 2 of the slides, and we cover the male reproductive system. I looked at the male reproductive system. I think it's like 12 slides. It's not a whole lot. So we'd have the second half of endocrine system, male reproductive system, that's next week. We would start female reproductive system week 8. We do digestive system week 9. So I'm sticking to my guns. I feel like we covered enough material that's going to keep us busy for this week, because Dexter's right. When we listed all of these, let me go back to all the different endocrine glands. We still have pineal, we did parathyroid. We still have pineal, we have pancreas.
Yeah, we have like 3 more pages of
we still have more stuff. Yeah. We still have more stuff to cover. So that's the plan for next week. So if you have not yet watched the crash course videos on the endocrine system, I highly recommend that you do that. I highly recommend you do that. I will add to my list of things to do this weekend. I will try to go in and separate the Kahoots and try to just buff up an endocrine system one. I'll just pull the endocrine stuff out and create its own Kahoot. And once that's done, I'll stick a link in Moodle so you guys can just click on it and access that Kahoot. It's fun. They're fun. Nice way of studying. And what else? Midterms. When I get home tonight from teaching class, I will start getting those graded. Grading tests on Moodle is a slow and tedious process. I can deal with one question at a time. I have to reload the whole page each time. And each midterm, I can only take them one question at a time. So it is tedious, but I will make my way through it. I believe you guys get notified when your final grades are done in there, so just be patient with me. But by tomorrow or tomorrow night, I should be finished with all of them. But I have classes I also have to teach tomorrow, so I'm booked tomorrow afternoon as well. So I will get to them as soon as I can, I promise. Haven't forgotten about you. All right. Good stuff, guys. Any questions? Any questions over anything we talked about so far?
Not a question, but a comment. Crash Course also actually has an app that you can download, and you can go and find like the different things that you're working on, and then it gives you like flashcard quizzes that you can do. It's super awesome. I went and got a tattoo the other day, and I was actually doing it on my phone during my tattoo appointment to like help study for things. Nice. Really easy to use. I love it.
Awesome. Crash Course app. Right on, man. Yeah, that's cool. I will have to look into that.
So in week 8, this is a weird question. There's the quiz that's due, and it's supposed to open tonight at 5:30. Are we supposed to start that or not?
Ooh. This quiz will not be available until May 13th. Well, golly, that's today. It will close Thursday, June 3rd. Yeah, I wouldn't worry about that because that is over the whole endocrine system, and we haven't finished the endocrine system yet. So even though it opens up, I wouldn't worry about it. It's due June 3rd. That's a Thursday, so it's the morning. We'd have class that day anyway. So I wouldn't worry about it just now. Like, it may be opening, but when they copied the course from last term in Moodle, you just copy it and paste it, and it just like translates dates over. I wouldn't jump on that quiz just yet. I would wait till after next week's lecture and you study a little bit.
You got it.
Yeah, because you said that was due week 8. Yeah, week 8, we will have finished endocrine and male reproductive system. So that'll be the quiz for endocrine. That's quizzes 3 and 4. And then after female reproductive system in week 9, you've got your reproductive quiz, and that will be over male and female.
Okay, just wanted to make sure that everything was okay.
Cool. Yeah, everything's good. Everything's good. The quiz opened a little early, but it can sit there and be open. All right, good stuff. Any other questions? Well, my friends, I know we're ending a little early today, but that's all I have. That's everything. We went over it 3 times. So if you guys develop any fun study tools or mnemonic devices, please share them. I would love to add them to the PowerPoints and use them in my future classes. But other than that, you guys study hard. You've got a lot to work on over the next week or so. Take it easy. Enjoy your weekends. And I will see you guys next week.
Thank you.
Thanks.
My
again.
pleasure.
Thank you.
Thank you.
The only reason why I really asked was because I didn't know when to completely stop with the notes, and I was like, oh, you know what? I'm just gonna go through all of it, and then I noticed I couldn't get all